Welcome to all my students. Here I am start the unit 2 electrostatic potential and capacitance. Main course content: 1 potential difference, 2 electric potential, 3 electric potential due to a point charge, 4 electric potential at an axial point of a dipole, 5 electric potential at an equatorial point of a dipole, 6 electric potential at any general point due to a dipole. Here I am start with the first point, potential difference. What is potential difference? Or define electrical potential difference between 2 points if it is a scalar or vector quantity. Look at the figure. Here I marked 3 points A, B and O. Plus Q, source charge located at a point O. Plus Q0, test charge placed at A in the electric field of source charge. Point B, a point in the electric field of source charge. When a test charge is placed at A in the electric field of source charge, according to Coulomb's law, there will be a force of repulsion. So, when a test charge is moving from A to B, work has to be done against the repulsive force. Let WAB work done in moving the test charge plus Q0 from A to B against the repulsive force exerted by plus Q. Therefore, potential difference between A and B is given by V is equal to VA minus VB, that is equal to WAB divided by Q0, where V and VB are the potential at A and B. Now we can define what is potential difference. It may be defined as the amount of work done in moving a unit positive charge from one point to another against the electrostatic force. It is a scalar quantity. The SI unit of potential difference is 1 volt. You have to define 1 volt. What do you mean by 1 volt? 1 volt is equal to 1 joule by 1 coulomb. The potential difference between 2 points in an electric field is said to be 1 volt if 1 joule of work has to be done in moving a unit positive charge of 1 coulomb from one point to the other against the electrostatic force. Therefore, 1 volt is equal to 1 joule per 1 coulomb, or 1 volt is equal to 1 Newton meter per coulomb. O is equal to 1 joule per coulomb. Second point is electric potential. What is electric potential, or define electric potential? In this case, the test charge is bringing from infinity to the point. Then work has to be done in bringing the test charge from infinity to the point. Look at the diagram. Plus Q charge is placed at O. Consider the point B in the B. And a test charge plus Q0 is bringing from infinity to the point B. Work has to be done. From this we can define electric potential. It is defined as the amount of work done in moving a unit positive charge from infinity to that point against the electrostatic force. It is a scalar quantity. Define the unit of electric potential. Unit of electric potential is volt. 1 volt is equal to 1 joule per 1 coulomb. We have to define 1 volt. The electric potential at a point in an electric field is said to be 1 volt if 1 joule of work has to be done in moving a positive charge of 1 coulomb from infinity to that point against the electrostatic force. Now we move to next topic, electric potential due to a point charge. Derive an expression for the electric potential at a distance r from a point charge q. Look at the figure carefully. Here I marked 4 points O, P, B, A. At O, source charge Q located at O. Test charge Q0 is placed at A in the electric field of source charge. P be a point at a distance r from O where the electric potential to be calculated. Suppose a test charge Q0 is placed at point A at a distance x from O. By Coulomb's law, the electric force acting on the charge Q0 F is equal to 1 by 4 pi epsilon 0 into QQ0 by x squared, where epsilon 0 is called the permittivity of free space. Its value is equal to 8.85 into 10 raised to minus 12 coulomb squared per Newton meter squared. Therefore, the value of 1 by 4 pi epsilon 0 is equal to 9 into 10 raised to 9 Newton meter squared per coulomb squared. The force F acts away from the charge Q. Let dW be the small work done in moving the test charge Q0 from A to B through a small displacement dx against the electrostatic force. Then work done dW is equal to vector f dot vector dx equal to f dx cos 180. But the value of cos 180 is equal to minus 1. Therefore, dW is equal to minus f into dx. Now the total work done in moving the test charge from infinity to the point P will be W is equal to integral dW is equal to minus integral infinity to r f into dx. But f is equal to 1 by 4 pi epsilon 0 into QQ0 by x squared. Substituting the value of f in this equation, then W is equal to minus integral infinity to r 1 by 4 pi epsilon 0 into QQ0 by x squared into dx equal to minus 1 by 4 pi epsilon 0 QQ0 into integral infinity to r x raised to minus 2 into dx. The integral value of x raised to minus 2 into dx is equal to minus 1 by x. Therefore, W is equal to minus 1 by 4 pi epsilon 0 into q0 into minus 1 by x within limit infinity to r. That's equal to 1 by 4 pi epsilon 0 into q0 into 1 by r minus 1 by infinity, or W is equal to 1 by 4 pi epsilon 0 q0 by r. Hence, the work done in moving a unit test charge from infinity to the point P, or the electric potential at point P, is given by V is equal to W by Q0 is equal to 1 by 4 pi epsilon 0 into Q by R. Thank you.